So hey everyone, welcome back to another video, and today in this video we are going to discuss our third sorting algorithm, that is insertion sort. So in this video we will be going to discuss like what is insertion sort, its algorithm in C++, why it is called as insertion sort, time complexity and space complexity. So without any further delay, let's get started. But before starting the video, please like, share and subscribe to my channel for keep motivating me for bringing more such content. So let's get started. So let's discuss first why it is called an insertion sort. This is not actually algorithm we are going to discuss. We are just going to visualize like how array will look like after insertion of every element. For example, we are given this array 43152, right? Now in this array, if we have single element, that is always sorted, right? If we have two element, this is sorted. You can see these three elements are sorted. You can see these four elements are sorted. You can see these five elements are sorted. So you have observed one pattern that once first element will become sorted, then two elements, then three, then four, then five, right? Now let's focus here. Since one element is sorted, 3 will say, now after this sorted part 3 comes. 3 will say, where can I come in your sorted part? So 4 will say, you can come before me. So that will become 3, 4. Now when we come to 1, 1 will say, where I can come in your sorted part? 3, 4 will say, you can come before us. That will become 1, 3, 4. Now 5 will say, where I can come? 4 will say, you can come after me. That is 4 after 5, right? 5 after 4. Now when we come to 2, 2 will say, where I can come? 1 and 3 will say, you can come in between us. So that will become 1, 2, 3, 4, 5. So you can see how insertion is happening. One by one, elements are getting sorted. Like last element after sorted part is getting sorted, and next element comes, then again comes in between. The next element comes, then again comes this in between sorted part, right? So you can see one by one element are getting inserted at their sorted position. That's why it is called as insertion sort. So let's understand like what is the definition of insertion sort. It's that same. It's a simple sorting algorithm that works by iteratively inserting each element to the correct position in sorted part of list. You can see in the sorted part of list, we are actually inserting in correct position, right? And that will become again sorted, right? So that is the insertion sort. Now before understanding the algorithm, let's get the intuition like how these elements are getting inserted in between, right? For example, let us consider this array only 1, 3, 4, 5, 2. Now in this array, how it will look like after inserting 2 like this. So if I write like here 1, 2, 3, 4 and 5, right? Now here you can see like 1 is 1. 5 is coming ahead, 4 is coming ahead, 3 is coming ahead, and 2 will come and insert in between. Have you observed something here? Exactly, we have observed that whenever elements greater than 2 comes, whenever element greater than 2 comes, they will be shifted ahead, right? And whenever element smaller than 2 comes, after that only insert it, right? Why it is getting shifted? Obviously, since this part is sorted, 2 will come in between any of them. So the remaining part, wherever let's say 2 comes here, this will be same, but 4 and 5 will be shifted here because 2 is coming in between. Like 4 and 5 will shift their position and take the 2's position, and 2 will come in between and take theirs position, right? So that's why it is named as insertion sort. So let's do the algorithm. We will better understand like how this happening and how it is making finally the sorted array with us, right? Let's create a temporary variable for now. Let's say 4. Now if we come to 4, 4 will say there is no one before me. So obviously array will be same as it is, right? So array will be same. We will say it will become 4, 3, 1, 2, 5, or it's better to start the iterations for temp is equals to 3, that is second index. Why? Because first index always don't matter for us, right? Now when we come to 3, we will say like to 4, are you greater than me? Yes. let's shift yourself. So 4 will come here. Now this is the 0th position. So you can see this is the only position that is left with us. Why? Because 4 has shifted ahead. Consider this as empty spot now because 4 has been shifted. So here 3 will come. So our array will become now 3, 4, 1, 2, 5. So this part of array is sorted now. Let's come to 1. So temporary variable is 1. 1 will say, 4, are you greater than me? Yes. Let's shift yourself. Let's move the pointer here. Instead of here, we are moving pointer here. 3, are you greater than me? Like 3 is greater than 1. So we will shift ahead. So now finally, only single element is left. Like single empty spot is left at the end. So we will add the 1 here. So now array become 1, 3, 4, 2, 5. Have you observed something? Yes, we observe that 3 elements are sorted. Now when we say temp variable is equals to 2, now 2 will say that since this part is sorted, 2 now pointer is here, right? So 4 is greater than 2. Yes, shift it here. 3 is greater than 2. Shift it ahead. Now pointer comes here. 1. 1 is less than 2. Don't shift. And at the end say, since this was an empty spot, because it was shifted ahead, so this was an empty spot for now, where 1 can shift, but it didn't shift. Why? Because 1 is less than 2. So we'll say 2, you can come here. So 2 will come here. So a new array becomes 1, 2, 3, 4, 5. So this was actually the best example where we were inserting 2 in between, like 3 and 4 shifted, but 1 didn't shift. Why? Because 1 was less than 2, right? Now comes 5. 5 will say, like temp variable is 5. 5 will say, are you greater than me? No. So just don't go ahead because it's always sorted. Is 4, if 4 is smaller, now obviously 3 is also smaller, 2 is also smaller, 1 is also smaller. So you can say the final array becomes 1, 2, 3, 4, 5 only, right? So this was insertion sort. So what we were doing, so how it was happening, like we were just traversing the elements one by one and we were finding, are you greater than me, are you greater than me, and we were shifting the elements ahead, and that empty spot that is left, we will place the element, like that temporary element at that position, right? So this was insertion sort. So let's understand the logic. So we will start the for loop from I is equals to 1 instead of 0 and go till n minus 1. And then what we do, we will create a temporary variable. That element that we'll consider is array of I, and we are considering a j pointer which will start from I minus 1, that is before that element. So for example, if we are considering 2, we will start from this sorted part, that is I, and j is I minus 1, and we will traverse in reverse direction and check if element is greater and greater, like that. So we will say while j is greater than is equal to 0 and array of j is greater than temp, till then shift the element ahead, that is array of j plus 1 will become array of j, and we will say j minus minus, and at the end what we will do after considering all these things, replace the next element. Why not j? Let me tell you, like when we were traversing the elements like this 2, so let's say this is 3 and 4, so 2 will say okay 4 will come here, 3 will say 3 will come here. So we are at this point, right? Since array of j is greater than is temp, so this pointer will go before minus 1, so it should be at 0. 2 should come at 0. Why? Because pointer will come, because j minus minus pointer will come before, but actually we need to go ahead. For example, if we have 1, 3 and 4 and 2 is coming, so 2 will say this, 4 will come here, 3 will come here, pointer will go at 1, but actually we want to insert at next point, right? So that's why array of j plus 1 is equals to temp. So let's jump to the editor and write the code. So yes, let's start here. Firstly, what we will do, like we will create a for loop, and let's write the array size for now, create the array size variable, and we will start from n minus 1, like n and I plus plus, and every time we will create a variable array of I. Then we will say j is equals to I minus 1 while j is greater than 0 and array of j is greater than temp. Till then, array of j plus 1 is equal to array of j minus minus, and then array of j plus 1 is equal to temp. Let's compile and run the code and check whether it's working fine. Yes, let's submit the code. So yes, it's totally working fine. So let's jump to the time complexity and space complexity. So since we were running two nested loop, so it can be big of n square. But what can be in best case? In best case, for example, we had this part 1, 2, 3, 4. 5 comes, 5 will say 4, are you greater than me? No, just loop breaks here only. This loop will no more go than one position. So that means in the best case, time complexity can be n. Right? So that is a best case and worst case time complexity. What is the space complexity? Big of 1 because we are just considering extra temp variable. Right? Now, let's discuss the advantages and disadvantages. Advantages are simple and easy to implement. Stable sorting algorithm. Because, for example, I have discussed many times stable sorting. If we have 1, 2 and we have 1 here. So if 1 comes, so 2 will come here. Now temporary is 1. So add then 1 is here. So 1 will say I will insert here only. So like you can see, this is the first one, this is the second one, and at the end this is first one, this is second one. So relative position of elements didn't change. Same elements 1, 1, like first and second are same. This is first one, this is first one, but this second one will not come before, right? That is a stable sorting algorithm. And it's efficient for small lists. Why? Because we are just iterating till the last, like we are comparing, are you greater than me, are you greater than me, and it will, at the worst case, it can compare all the elements. So small list is fine but not efficient for large list. It is less efficient than merge sort and quick sort. So this was all about video. If you like the video, please like, share and subscribe to my channel for keep motivating me for bringing more such content. Thank you and have a nice day.